Alright, we're going to start in about a minute here. But if we have any questions about last night's assignment, now would be a good time to ask, because you're going to probably have to have that mastered for today. That needs to be a pretty well-oiled machine, so to speak. So, any questions about last night's homework? If not, that's what we did yesterday, two-step equations. So today we're going to be looking at multi-step equations. And again, there is a PowerPoint in the Google Classroom you can follow along with if you want some written notes out. This video will also be recorded and posted, so you can view this later as well. But before we start with multi-step equations, you need to have these two things pretty much down pat. So two-step equations, which is what we did yesterday, and combining like terms, actually. And I'd like to spend the first minute or so here going over combining like terms. It's probably been a while since you've done it. And again, a like term is going to be terms that have the same type of variables. And these include terms like, hey, I can combine x with another x. Like x plus x, I get, hey, this is just repeated addition. I'm repeating the addition of x twice, so that's multiplication, so that's just 2 times x, or 2x. And again, you can have like multiple of them. You can be like 3x plus x. I have 3 x's here, and then I'm adding another x to it. That's equal to 4x. So you can combine those like terms like that. So you see this is a like term, this is a like term. They have the same kind of variables there. This has the same kind of variable as this. Things you can't do. You cannot combine this because these variables are different than this variable. So this is just going to be 3xy plus x. You can't change that at all. You can't combine them. You can't do much with it. It's just what it is. Also, you cannot combine different exponents. I guess I should mention that. So 3x squared plus x equals 3x squared plus x. You can't combine those either because the variables are different. That's x squared and this is just x. They're not going to go together as well. But hopefully combining like terms is a review. We did take notes on it a while ago. But basically what we're going to do is we're going to take things where we combine like terms and we're actually just going to solve the problem. So before we were just combining like terms, and then yesterday we were just solving two-step equations. Now today we're going to combine like terms to make it into a two-step equation and then solve that. So again, if you're following along with the PowerPoint, the first one that, or the first question that was posted, and I'll walk you through it. You can take notes on the step, or you can read the PowerPoint so it's clarified. But we have the problem m plus 2m minus 4 equals 14. So the first thing you want to do is you want to get one variable. If I have one variable, I can solve this. That's not a very good R either. If I can get one variable here, then I can solve it because then it just becomes a two-step equation. I can't do anything with this negative 4 because there's no other like term. Sure, the 14 is a like term and we'll deal with that later, but it's on the other side of the equal sign, so I gotta do that. Deal with that afterwards. Over here I have an m, and over here I have a 2m. Those I can combine, and I can actually do m plus 2m. m plus 2m is going to give me 3m. And I couldn't do anything with that -4 yet, so I'm just going to tack it on. And I didn't touch the equal sign, and I didn't touch the 14. So once you combined your like terms, you now have a two-step equation right here. This is what we did yesterday. You now have a two-step equation, and you can draw your line and you can solve. So here I have, again, order of operations in reverse. I'm going to do -4 first, get rid of that -4. So I'm going to add 4 to this side, and I'm going to add 4 to this side. This is going to cancel, leaves me with 3m over here, and 14 plus 4 gives me an 18. Then I want to continue with my order of operations in reverse. And divide this by 3 and divide this by 3 as well. I already started this, Luke. Can you not hear me? Can you hear me? Type in the chat if you can hear me. Okay, sounding like it's just Luke's issue. Hi, Logan. Yeah, okay. But anyways, once you divide by 3, your 3's here will cancel. Leaves you with m equals, and then 18 divided by 3 gives you 6. And then again, you can go ahead and plug that in. So 6 plus 2 times 6 minus 4 should equal 14. 2 times 6 gives you 12. Uh, 6 plus 12 minus 4 gives you 14. 6 plus 12 gives you the 18. 18 minus 4 gives you the 14. So you can check things out. So again, all of what we're doing today is combining like terms and then solving the two-step equation that it gives you. And I will go over a few examples, and I got some pulled out from the book for you to work on to do as well. It's easy to delete this one. But just some things to look at. And again, if you're following the PowerPoint, it's going to ask you this question here. So let's go ahead and look at this question here. So this would be an example of, hey, when am I actually using this? Right? So here we have the sum of 3 consecutive integers. And again, consecutive means that they're right next to each other. So make sure you know your definitions there. Consecutive meaning right next to each other. In other words, your numbers are like 1, 2, 3. These are consecutive integers. 5, 6, 7 are consecutive integers. 24, 25, 26 are 3 consecutive integers. So they have to be the numbers right next to each other when they come to integers. I didn't delete it. So those are your consecutive integers. I screwed up the layers. So when you get ahead and you can actually set up the equation for this, I know 3 numbers added together has to equal 96 here. and they have to be 3 consecutive integers. So let's say I want the first integer. So the first one, the first number, I'm going to call n. I'm going to call that n. So this value here has to be n. This value here, being a consecutive integer, has to be 1 more than n. So I'm going to call that n plus 1. That way it's 1 more than n. And then this last one over here has to be 1 more than n plus 1, or 2 more than n. So I'm going to call this n plus 2. And that's where I get my different variables here. So if I were to rewrite this a little nicer, it's going to be n plus n plus 1 plus n plus 2 equals 96. And if you take a really close look at it, you'll realize that, hey, everything here is just addition, so I really don't even need these parentheses. So let's get rid of those parentheses. And then, again, everything's addition, so everything is commutative, so I can rearrange this any way I want. So I'm going to rewrite this as n plus n plus n plus 1 plus 2 equals 96. And then once you get to that step, or, I mean, honestly, you could probably skip that step if you can do it in your head, but we're going to combine all our like terms. You'll see that we have 3 n's together, so these 3 n's are going to become 3n. And 1 plus 2 we can combine together, which will be 3. And that equals 96. And now you're back to that two-step equation that you did yesterday. So go ahead and solve the two-step equation. I'm going to subtract 3 from both sides because I do order of operations in reverse. That leaves me with 3n equals, and 96 minus 3 gives me 93. And then I'm going to divide each side by 3. Again, this is going to cancel. Divide by 3, divide by 3. This will cancel. 3 divided by 3 is 1. I'll write it down here. So this leaves me with n. 93 divided by 3 gives me 31. So I know that my first number, n, is equal to 31. And if I know my first number, I can get my second number, because my second number has to be n plus 1. So n plus 1 equals my second number. So 31 plus 1 equals 32. So my second number, so first number is that, second number is 32. And again, third number is going to be 33 because they have to be consecutive. And you can go ahead and check that out as well. If you added all these up, you get 3 plus 2 plus 1 gives you 6. And 3 plus 3 plus 3 gives you 9. So there you go. You were able to solve this problem here, a consecutive integer problem, by using some algebra. Any questions on how we did any of this? The chat's been kind of quiet for a while here. And again, all of this is written out in the PowerPoint as well. All right, if there's no questions, we'll move on. The next thing we need to cover for today is doing this with the distributive property. So the distributive property we've been working with all year and we'll continue to work with. Property, and this is the kind of thing where it's like 3 times x minus 2 or something, and you distribute the 3 to the 2 and you get 3x, because 3 times x is 3, and you get 3 times negative 2, which is negative 6. So this is taking things like this and moving it into this. We're just going to add this as a step for combining like terms. Normally when it comes to distributive property, it is something in parentheses, so you tend to do it first and get rid of it. However, sometimes on certain occasions it's better to leave it the way it is before you deal with it. But for the most part today we're going to get rid of the distributive property first, and we'll see how we do that. So again, if you're following along in the PowerPoint, there are a couple examples there. The first one is 2 times 5x minus 3 equals 14. And you want to solve for x here. This is no longer just simplifying things. We actually want to solve them. So here we're going to solve for x. And the first thing you need to do is distribute. So I'm going to take the 2 and I'm going to multiply it by 5x. And I'm going to take the 2 and I'm going to multiply it by negative 3. 2 times 5x I can combine and make that 2 times 5, which is 10, and I can't really multiply by the x, so I'm just going to tack it on. And then 2 times negative 3 I can combine. I can do 2 times negative 3. 2 times negative 3 gives me a negative 6. And that is going to be equal to the 14 that is over there. And now it becomes your two-step equation. So with that, order of operations in reverse tells me to add 6 first. Add 6 on both sides. This is going to cancel. Leaves me with 10x over here. And 14 plus 6 gives me 20. Then to get x by itself, I need to divide this by 10, divide this by 10 as well. If I do it to one side, I do it to the other. This will cancel. Leaves me x, and over here, 20 divided by 10 gives me 2. So x equals 2 here. And again, you can plug that back in to check your work. So if I have 2 times the quantity 5 times 2 minus 3 equals 14, do parentheses first. This becomes 2 times 10 minus 3 equals 14. This becomes 2 times 10 minus 3 gives you, was that 7? Equals 14, and then 2 times 7 equals 14, which equals 14. So you know you can check your work as well. The next example given was 38 equals a negative 3 times 4y plus 2 and plus a y. This one you're going to have a little more combining like terms to do, but our goal here is to get it so it only has one y value. Here you have two y values. We want to combine our like terms. And the first step is the distributive property. So we're going to ignore the 38 equals. We're not going to touch that yet. And we're going to distribute this negative 3 to both these. Now this negative sign is coming with it. It is attached to that 3. So be careful when you do your integer stuff. So we're going to have negative 3 times 4y, which is going to give me negative 12y. And we're going to have negative 3 times positive 2, which is going to give me negative 6. And then we didn't touch this y. It's not inside the parentheses here, so we don't distribute to it. It just gets tacked on at the end. Then I go to combining my like terms. I got to get these two y's together and combine them to make it so I only have one y variable. Again, not touching the 38 equals yet, not on that side. Negative 12y combined with a positive y. Remember, you get the sign in front, so I'm combining this positive y here with this negative 12y. And you're always going to add if you do it this way. So negative 12 plus a positive y. And remember, there's also a 1 in front of this y. That's 1y, not just y. You never write that, though. It's just implied. And then negative 12 plus y is going to give me negative 11y. And then the minus 6 we didn't touch. Once you get to this step, it is just the two-step equation that we did yesterday. You got your line. Again, this side here has the variable this time, so I'm focused on things over here. I have a minus 6 and a minus 11 times y. I can deal with the addition and subtraction first. So I'm going to add 6 to both sides because it's the inverse of subtracting 6. Add 6 there, add 6 there. 38 plus 6 gives you 44. And over here these are canceling, and we're left with negative 11y. Continue your two-step equation. Divide this by negative 11 to get y by itself. Divide this by negative 11. And this becomes a negative 4. Watch your signs. This is a positive and this is a negative. So when you divide them, you get a negative. Over here, they will cancel out. Negative 11 divided by negative 11 is 1. And 1 times y is just y. So here we've solved for y. And again, you can come back to the front, or the beginning here, and plug it in and see if it makes sense. We don't have the parenthesis yet. 3 times 4 times y being negative 4. So plug in that, plus 2. Then we have also plus another negative 4 over here. So again, do parentheses first. 4 times negative 4 gives you negative 16. Negative 16 plus 2 is going to give you negative 14. Now you're going to do negative 14 times 3, which I'm not using a calculator for that. Gives you, that would be a positive, because this is a negative times a negative, that will give you a positive 42. And then that's going to be plus negative 4 or 42 minus 4, which gives you that 38. So you can see that our thing at beginning. Can you just combine 4y and y at the beginning? No, you need to distribute first. You do need to distribute that, John. Because this isn't a 4y, this is actually a negative 3 times a 4y. And that gives you the negative 12. That's it for notes for today. Your assignment, which apparently James has started already, is in the book. So it is 1 through 23 odd on page 355, 1 through 23, and do the odd ones, please. And there is an answer sheet in your Google Classroom that you can just type in the answers there as best you can, and then submit that. If you have questions on that, I can do some of those right now. James is asking for 13, so give me a second to look up what 13 is. And we'll work on 13. So 13. Thirteen is saying negative 2 times a plus 3 minus a equals naught. Alright, so we have, first step is to distribute. So first thing we're going to do is just distribute. So I'm going to do negative 2 times a and negative 2 times 3. Again, this negative a does not get distributed to because it's not in the parentheses. So that's going to leave us with negative 2a because you can't actually multiply that. So we're just tagging on. And negative 2 times positive 3 is negative 6. And then we just have that negative a out front. And that's all going to equal 0. Then we can combine like terms, keeping in mind that this a is negative and this negative 2a is also negative. So when I combine them, I have negative 2 plus negative negative 2a plus negative a. In other words, there's a 1 in front of this, but again, you never write the 1. So this is 1a, but we don't see the 1, so just as a. So when I combine that, negative 2 plus negative 1 gives me negative 3a. I didn't touch the 6, and I didn't touch the 0. Once you're at this point, it is your two-step equation. So this is your two-step equation. And again, order of operations in reverse. You're going to add 6. You're going to add 6. These will cancel, leave you with negative 3a. 0 plus 6 gives you 6. Still working on getting a by itself. So you're going to divide this by negative 3, divide this by negative 3. Negative 3's will cancel into a 1. A equals 6 divided by negative 3. Now the 6 is positive and the 3 is negative, so your answer is going to be negative. And 6 divided by 3 gives you 2. And you can go ahead and plug it back in and double check. So negative 2 times negative 2 plus 3, all minus a negative 2, should equal 0. Distribute that out. We get positive 4 plus negative 6, and then minus a negative is just plus 2. Combine these terms, you should be getting 4 plus 2 gives you 6, and then 6 minus 6 is 0, but so yeah, it does work. 4 plus negative 6 you might want to do first. I don't know, depending on what you're thinking. And again, that's just a subtraction sign. So 4 minus 6 gives you negative 2 plus 2, which equals 0. Are there any other questions on any of the problems? Looking through them, seeing if you can understand them or not. Number 5 is negative 3. I don't know. I didn't do it. Number 5 is negative 3, yes. Number 5 is negative 3. That's fine. You can ask questions all you want. I'll look at everyone's answers and see if things are making sense as well. But normally math makes sense, and you can always plug it back in and check yourself too. I will remind everybody that the grading period ends tomorrow. So if you are missing work for science, anything that is on option C, double check to make sure it is done for tomorrow. Your online quizzes will not be graded until tomorrow, so those will be blank until then. but make sure if you're missing anything, you're turning things in. Feel free to take pictures of things and email me pictures. Feel free to attach things into drop boxes, which makes my life easier if you do it that way, so everything's in one place and I don't have to shuffle through my emails and stuff. But whatever. But yeah, I believe I just wanted you to do the worksheet today, and I put a discussion question in as well. Yeah. I have set up for math your worksheet that you're working on now for multi-step equations in your discussion post. And again, discussion posts are due at the end of the week, so you have time to actually see what other people are writing, and you have time to read what people are writing. Your discussion question is kind of old if you remember back when we were doing exponent rules as well. But if there are no further questions, then I guess we're done here for today. Thanks for coming out. Again, as always, this will be recorded and posted. If you need to reference it again, feel free to send me emails. A few of you have been sending me emails with questions about specific problems. I can quickly record you a video on how to solve that specific problem and send it back to you. It's been working for other people, so if you have questions, let me know. And if not, I'm going to end the stream here and look forward to tomorrow's class.